Hi class, today's lesson is 12-3, Counting Methods and Sample Spaces. This is a lesson in our probability unit, so let's take a look at the purpose. Our purpose for today is to use different counting methods, and I'll talk about 3 of them, to use different counting methods to determine all the possible outcomes. We have only one vocabulary term, so go ahead and turn to the back of your composition books to record this one term. And that term is sample space. What is sample space? Sample space are all the possible outcomes of an experiment, and they're denoted with brackets. All right? You'll see some of this as we go through the examples. First example is a problem-solving application, and we're going to use the counting method of essentially a tree diagram. You'll see what I mean here very shortly. In winter, Judy has a choice of 2 coats, a ski jacket or a pea coat. She has 3 accessory choices, a hat, scarf, or gloves. What are the different outfits Judy can wear? Now we're assuming that she can only pair one accessory with one coat to make this a little more simple. So first thing we do for this tree diagram is go ahead and write down ski jacket. The next thing, we're going to skip some space here, and you'll see why, and write down the pea coat. If you've ever seen a pea coat, it looks much like, well, the coat that old sailors used to wear. Not old sailors, what sailors used to wear of old. Here we go. We're going to make trees or branches. Oh, wow. Those branches are rather crooked, but then tree branches are generally crooked, aren't they? Oh, but that is really crooked. Oh my goodness gracious. But hey, it's a tree, right? Tree diagram. So the first pairing of a jacket with an accessory could be a ski jacket with a hat. Another pairing would be a ski jacket with a scarf. Another pairing would be a ski jacket with gloves. Again, we're assuming only one accessory paired with each jacket. For the pea coat, we could choose the hat as well. We could choose the scarf, or we could choose the gloves to go along with that particular jacket. In the end, we have a total of 6 outcomes: ski jacket, hat, ski jacket, scarf, or ski jacket, gloves. Or we can choose the pea coat and have it with a hat, pea coat with the scarf, or pea coat with the gloves. That's an example of a tree diagram. Next, we'll show you an example of an organized list, making an organized list. Here, Marissa is shopping for a portable MP3 player. The player comes in black, silver, and red. She can choose between models that store 120 songs, or I should say 120 songs, or 240 songs. What are all the possible MP3 players Marissa can choose from? So once again, we're going to determine the outcomes, but this time with a list. So I'm going to go ahead and list out the first thing, which was the black model. And black model can come with 120, or the black model can come with 240 songs. Then there's the silver. Silver can come with 120, or the silver can come with 240 songs. Then we also have the red. And the red version can come with 120 songs, or the red version can come with 240. What are all the possible players that she can choose from? Well, these are essentially all the players or all the outcomes that she has. Black 120, black 240 songs, silver 120, silver 240, red 120, red 240. It's another way, just a list. Finally, we'll get to the last counting method, and that's the fundamental counting principle. This is actually sort of a shortcut. It's by a use of multiplication, a method in which to find all the outcomes. Here it says students at Jefferson Middle School must take one fine arts class and one athletics class. The fine arts class choices are band, orchestra, choir, and art. So there are 1, 2, 3, 4 fine arts choices. And then the athletics choices are PE, soccer, basketball, volleyball, football, and tennis. How many possible combinations are there? And again, we're looking at combinations of fine arts class paired with one athletics class. One way to do this is to look and see how many choices we have of the fine arts. We have 1, 2, 3, 4. There are 4 choices for fine arts. And there are 1, 2, 3, 4, 5, 6 choices for athletics. Now, what this fundamental counting principle says, we can figure out what all the pairings are by simply multiplying these two numbers together. 4 times 6 equals 24. Now, if we were to go ahead and do this by another method, whether it be the tree diagram or whether it be the making a list, we would find that there are exactly 24 outcomes when a fine arts class is paired with an athletics class. This is just a shortcut, and we all appreciate mathematics shortcuts. Lastly, complete the problem. Wow, look, there's no complete the problem. You're going to have the opportunity in class tomorrow to complete some problems. What I want you to go ahead and do, though, is be able to articulate why this would work. Why this would work. Why does the fundamental counting principle work? Does it work with those other examples that we showed earlier? All right, that's it, and we'll see you in class.